how you did. So on your screen right now, you should see how you did on it. And I want to talk about some of these because this is basically what we talked about last time. And so I want to make sure that everybody is feeling comfortable with how we solve these types of questions. So let me all right, so last time, so we got to here on the 10.6, and we talked about changing it to vertex form, and then, but we want to make sure that we understand the difference between changing something to vertex form and when it says to solve it. So let's look on the next page here. I want to look at this part B. I changed it just a little bit because of the way that this is written out here, it actually causes, I don't know, it just has a lot of crazy fractions and stuff in it, and I don't want you to get bogged down by the fractions. I just want you to be able to make sure that you know how to do completing a square, to either write something in vertex form or to be able to solve a quadratic equation. All right, so let's first do, so this first one is going to be the vertex form. All right, so we'll work on that over here. And so if we're given standard form of y equals 3x squared plus 12x, and then I'm going to change this here to a -6 instead. All right, so I would need to add that over to the other side, so I can get this in this form here, so -6. All right, so if I'm trying to change this to vertex form, remember that the first thing I want to do, if I have a leading coefficient that is not 1, I've got to factor that out of the first two terms. All right, so I'll have y equals, and then 3 is what's going to factor out of both of those terms, leaving me with x squared plus 4x. All right, and then I still have this -6. All right, and then in the next step is where I put the blanks in, right, for my completing the square part. So I'll have y equals 3 times x squared plus 4x. And then I'm going to put plus blank. All right, so remember when I'm making that perfect square trinomial, it's always going to be a plus sign here at the end. So plus blank, and then -6. And then if I'm adding a number to an equation to keep that balance, I need to subtract off that same amount. All right, and so now I need to figure out what goes in my blank here. All right, so I do half of the middle term, so half of 4 is 2, and 2 squared is 4. So 4 goes in here. Then I'm not going to put 4 here because it's not really 4 that I've added to this, because I have this times 3 on the outside here. All right, so 3 times 4 is 12. So 12 is what I really added here. So I need to make sure that I subtract off 12. All right, now let's get this next step. We'll have it in vertex form. So we'll have y equals 3. And then if I factor this, right, we made this into a perfect square trinomial, so that will factor to be x plus 2 all squared. And then, wait a minute here. Oh, I shouldn't have had this as a -6. That should have been a +6. Said anything earlier, right? Because I was adding that over to the other side. Sorry. So that is not right there. Okay, and so then I'll end up with a -6 there at the end. All right, so that should be the answer there that you got on that first part. What questions can I answer about that vertex form? Just unmute yourself and ask me if there's some things that I can help you with on that and help you understand better. Okay, well, let's look at how to solve this also. Okay, so the other part, all right, so the second question on that quiz wanted you to solve 3x squared plus 12x equals -6. So again, it kind of starts off the same where we still, if the leading coefficient is not 1, we've got to factor that out. That 12 looks really weird. All right, so I'm going to factor that 3 out, and that will leave me x squared plus 4x. Right, and then I still have this equals -6. Remember, I'm not factoring anything out of that constant term in either way that I'm doing this. Right. But now the next step again is I'm going to put those blanks in. So 3 times x squared plus 4x, right, plus blank. And then I'm going to have equals -6. And again, it's going to be plus blank. And I want to make sure everybody understands why we're going to be doing, why are we adding here? Oops. So -6 and then plus blank. Anybody tell me why? Like on this one we added a number and then we subtracted this number off here, but notice that the blanks on these two both are plus blank and plus blank. Somebody tell me why that is? Because that's a really important part, the differences between these.
Would it be because it's equal to, like we're solving for it?
Yeah, and remember whatever you do to one side of the equation, right? You'll always do the same thing to the other side of the equation. Where over here, these are on the same side of the equation, right? So to keep it balanced, we add the number, subtract the number off. To keep this balanced, we add the same number to both sides. Awesome. All right, so same thing, half of the middle term is 2, squared is 4, so 4 goes in my blank here. But then remember, it's not really 4 that I added to this side of the equation. I did 3 times 4. So 12 needs to be added to the other side. All right, now let's write this. Let's simplify this up a little bit. So I've got 3 times, this is a perfect square trinomial. Remember, that's the whole reason why we do completing the square, to make this perfect square trinomial. And so then that will factor to be x plus 2 times x plus 2, or we can write that as x plus 2 all squared. All right, and then that's going to equal a positive 6. And then when I'm going from here, right, I'm trying to get the x by itself, but I've got all this other stuff around it that I need to get rid of first. So first of all, if there's a number out in front, right, that's being multiplied there, I need to divide both sides by that number so that I can get that x, or that squared part by itself. Right, so I see my 3's divide out there, so that's good. And then I'm just left with x plus 2 squared equals 2. All right, just simplifying that. And now I just need to take the square root of both sides. All right, so over here, that's square root and the square. All right, undo each other, and I'm left with x plus 2 equals plus or minus the square root of 2. Remember that, or sorry, I said the square root and I forgot to put the square root in. Let me write that again. So remember that you're going to have, whenever you're taking the square root, right, you've got to write this as a plus or minus. So remember, we're going to end up with 2 answers when we're solving quadratics. And then the last thing I need to do is just add, or sorry, subtract my my negative 2 over. So I've got x equals negative 2 plus or minus the square root of 2. Right? And then if you change this to decimals, right? So I asked you to kind of do that. Let's see, I'm going to come up here just to make sure we're seeing. So one of my answers is going to be negative 2 plus the square root of 2. And the other one is going to be negative 2 minus the square root of 2. And then I just need to put those into my calculator and simplify what we get there. And so if you are still not sure how to, kind of do some square root stuff on your calculator, make sure that you ask about that, because that's going to be something that you're going to need to make sure that you know how to do for the test. Right. Let's see. So if I do negative 2 plus the square root of 2.
Why did I?
What was that? Does somebody have a question? I don't hear you. All right, so if I do negative 2 plus the square root of 2, that should be negative 0.5857, blah, 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 so 0.6, right, on that, so negative 0.6. And then when I do negative 2 minus the square root of 2, I get negative 3.4. So that's how I get those two answers. What can I answer there for you or clarify? Any questions you have there?
I was just wondering why on one of them you did a negative 12 and on the other one you did a positive.
Yeah, so notice that over here on this one, when we're trying to get it in vertex form, notice where our equal sign is, right? We have y equals all of this stuff. So when we do complete the square here, we've got 4, and then we have to do 3 times 4. So really on this part, we added 12 here. And so to keep it balanced, I need to subtract the 12 off. All right, so if I had, just like 3x plus 2, all right, y equals 3x plus 2 or something like that. And if I said, okay, I can't just add 4 to this. I'd have to add 4 to this side and add 4 to the other side. But I want to keep everything on the same side when I do it in vertex form. So I'm going to add 4 and then subtract 4. And then that really didn't change anything, right? That just is adding 0. But it helps me put things in a different form so that I can, and we're going to talk about today how this is going to help us graph it. All right, but over here, right, notice where our equal sign is. We're adding 12 to one side of the equation, so we've got to add 12 to the other side when we're solving that. Does that make more sense? Because that is kind of like the tricky part between these two, and keeping those straight and understanding why you're doing that is going to help you to remember what you need to do when. It's a good question. Other questions?
I have a question.
Yeah.
I think I know the whole steps, but I think I'm just lost on how and where we get the middle term. Like where we got the 4 and 12. I know where we got the 12 by 3 times 4, but how do we get the 4?
So this 4? I'm not sure which 4 you're talking about. The 4x?
The one in purple.
The one in purple?
No. Yeah.
Okay, the one in purple. So completing the square means that you're going to half, right? So take half the x term, right? So that's 4 in the middle. So half of 4 is 2, and then square that number. Okay, and
so we're getting that from the middle number then, basically?
yeah, we're getting it from this middle term here. Right? So you're just going to always look at that. Okay, what's my x term? Right? It's a 4, that coefficient there. I'm going to take half of that. Right? So 4 divided by 2 is 2. And then I'm not done. Then I need to square it. Right? And so 2 squared equals 4. It just happens to be that this one is the same. It's not usually going to end up being the same. Right? Only if we have a 4 in the middle there. Because if we had a 3, or sorry, let's say a 6 in the middle, right? If we had 6 in the middle, 6 divided by 2 is 3. And then when I squared that, it would have been a 9 I would have added there. Does that make sense?
Yeah, I think it does.
So that's this whole thing that I put here in purple. This is what I mean by completing the square. It's where you put these blanks in, take half of the middle term, and square it.
Okay. Thank you.
Yeah. Anybody else have a question about that or a comment in like how you remember this or what's helped you maybe? All right, well, turn the page and I want to look at the next thing that we have here. So we have these 4 different questions. And so we've talked about some different ways that we can solve quadratics so far. So I'm going to put those up here. All right, so we said we can solve quadratics by factoring them. All right, so we talked about that. And then we also talked about being able to use that square root property. And so sometimes we're going to have to use completing the square to use that square root property. Okay? And we've also talked about graphing. We could, solve quadratics by graphing them as well. All right. And then today we're going to talk about one other way that we can solve these quadratics. So there's a lot of different ways that we can do it. So if they can't be factored, we've got other methods that we can use in order to figure out, those. And remember, when we're solving for x here, what we're really finding are the x-intercepts. Where is that parabola crossing the x-axis? Right? That's an important part of our parabola. And remember, those x-intercepts could also be called zeros. Sometimes they call them roots. Right? Just kind of depends on the book and stuff, but you'll see those. Those of you going on to 1050, they'll kind of use all 3 of those terms interchangeably. If they want you to find the zeros, they're saying find the x-intercepts. If they say find the roots, they want you to find the x-intercepts. Okay? Kind of the same thing there. All right, let's do this first one together. I want to just kind of see, I want you to think about the different ways that we could solve this, right? So decide which method for solving the quadratic would be most efficient, and then solve it. All right, so on this one, I'm going to look at it and say, well, it might factor. All right, so I want to try and look at this first and see if it would factor. So I'm going to write that out here to the side, all right, just to see. So to factor this, when that leading coefficient is a negative, I first of all want to take that out, like take that greatest common factor of -1 out, because it's going to make the rest of this easier to factor if I go ahead and divide that -1 out. Okay. Then I'm going to see if this will factor, right? So I'm going to do that method where I say, okay, what, do the first and the last term multiplied together. So 2 times -5 is -10. So what multiplies to be negative 10, right, that adds to be the middle term, which is negative 9. Right. So it looks like it's going to be 1 and 10, but which one is going to be negative? Which number needs to be negative?
The negative 10. It would be negative.
Yeah, because 1 times negative 10 gives me negative 10, and then 1 plus negative 10 gives me a negative 9. Right? That's what I'm looking at there. This today is just, I don't know why my pen is having issues today. All right, so then remember we've got to take and write this either as a 4-term polynomial, right? Or I can do that box method to try and get it factored. All right, so maybe I'll do that down here in purple. All right, so if I'm trying to do the box method here, then that 2x squared goes in one of my boxes. Right, and then remember I changed this, my middle term is no longer a negative 9x, I broke it down to be a 1x and then a negative 10x, right, because those together would give me that negative 9x. So I'm going to put my x, or my 1x, and my negative 10x. And then I still have that negative 5 down there. So however you want to do this, remember we talked about synthetic factoring, we talked about factor by grouping, we talked about this box method. I don't care which method you're using to factor this, right? But you can't go straight to the parentheses, because remember our leading coefficient isn't a 1, right? We can only do that when that's a 1. Otherwise we have to take this kind of long route, because we're figuring out 2 times negative 5 is what. Right, and then do that. All right, so then if I factor this out, it looks like an x will factor out of that part, a negative 5 will factor out of this, and then up here I've got a 2x that will factor out, right, and then just a 1 will factor out there. And so that means that when I write this down in factored form, right, so I still have that negative 1 out in front, don't forget about that. But then in my parentheses, right, I'm going to have 2x plus 1, because that was a positive 1 that we brought out. And then in the other parenthesis, we're going to have that x minus 5, right, over there. And now what do I do from here to solve it? So after I've factored it, what do I do now?
You set them to 0, is that right?
Yeah, that's exactly right. So set each part equal to 0. So if we do negative 1 equals 0, well, there's nothing there to solve for, right? So this is just kind of nonsense. That's not going to be part of our answer. If there was an x on the outside there to solve for, then yeah, we'd need to do that. Okay, but let's do the other two parts. So 2x plus 1 equals 0, and then our other factor, x minus 5 equals 0. And then we'll solve each of these for x. So subtract the 1 over, and then divide by 2. So x equals negative 1/2. And then here, we'll add the 5 over. So x equals 5. All right, so we end up with 2 solutions, and we are thinking that we should end up with 2 solutions because remember, our highest exponent, the degree of this polynomial, is 2. And that's telling us how many answers we'll end up with, right? Those could be imaginary, they could be real, right? But there's going to be that many solutions. There's going to be 2 solutions. All right, so it's been a little while since we've done this. doing the factoring, setting them equal to 0, solving. What questions can I answer here on this one? Did everybody see where I got all of those numbers from?
Question.
Yeah.
Where did you pull the -1 from the very beginning from?
So do you see how the leading coefficient was a negative?
Right.
So whenever that leading coefficient is negative, it's hard to factor this with that leading coefficient being negative. And so it's easier if we're factoring it out. We're dividing that -1 out of every single part, because that's our greatest common factor that can come out of everything.
Okay, cool. Thank you.
So whenever it starts with a negative like that, factor it out first.
Okay. Thank you.
Yeah. Great question. Is there other questions on that?
I have a question.
Yeah.
For the box method, I know you said, stop it. For the box method, how did you factor this out? Did you, like the -5, how did you get that?
Did you see, so you're thinking of what's the greatest common factor of both -10 and -5. So since they both had a negative, we want to factor that negative out with it. Right?
Okay.
And then 5 is the biggest number that we'll divide into both of those.
Okay. I think that makes sense.
Yeah, I know. Sometimes it's hard. Like sometimes people are like, well, why is that negative coming out? Well, if both of our numbers are negative, we're going to, in our box method, we're going to make sure we bring out that negative with it.
Okay.
Okay.
Okay, thank you.
Yeah. Okay, other questions? Right here, let me see here. All right, I am actually going to have you guys work on the rest of this into some groups. And so I'm going to have you work together for probably, I'm going to give you about 15 minutes, okay, to do this. And I'm just kind of randomly assigning you into some rooms with each other. So you might not be in there with people that you've worked with before, but that's okay. All right, I want you to just kind of talk about it, work together with it. And this breakout session hopefully will work a lot better than what we did before. That's what I've heard from other instructors, that this works better. Okay, so what I want you to do when you get out into your breakout session is I want you to finish working the questions on that page. So on page 134, you're going to do part B, C, and D. And remember, you want to think about the different methods that we've talked about and which one might be best to use for the different situations. Okay, and then if you have a question, you still can, you still should be able to raise your hand. Have you guys, let's see. No. So if you have a question, I think there's a place where you can still raise your hand, but I'll just kind of be going between the different groups and stuff too, so that we'll be able to, so you'll be able to ask me some questions too, but talk with each other about it, okay? And like I said, let's do about 15 minutes and try and get those 3 problems figured out so you can kind of talk it out a little bit, okay? Rachel, Peter, what did I say? How do we solve this one? Make sure you unmute yourself.
So we need to take the 4 out.
Okay.
So we get 4 parentheses x squared minus 6x equals negative 15.
Okay, awesome. Then what?
And then we need to add in our spaces to get the perfect square.
Okay.
And it's 4x squared minus 6x plus 9 equals negative 15 plus 36.
Right, because you had to do the 4 times the 9 to get that 36. Okay, then what?
So I couldn't hear the rest of my groups for after this part, so.
Okay, do you have an idea of what you think you might do next after this, or?
I wrote down 4x minus 3 squared
Yeah.
equals 21.
Yeah. Because remember, this is a perfect square trinomial, that x squared minus 6x plus 9, and so that factors to be x minus 3 times x minus 3. But we're going to write it this way so that we can use this square root property like we did on B. Right? Okay, then what do we do from there?
Divide the 4 out.
Yep.
So it'd be x minus 3 squared equals 5.25 or 21 over 4.
Yeah, and let's just leave it just as a fraction. You can change it to decimals as long as the decimals aren't like never ending, right? So if they're terminating, if they come to an actual stopping point on your calculator, you can change it to a decimal, but otherwise leave them as fractions. Okay, then what from there?
So you would add 3 to both sides and it'd be x equals.
So not quite yet. There's one thing we need to do first. Maybe you thought we did it already. How do we get rid of that squared?
Square root it.
Yeah, so let's square root both sides first. Right, so now we got x minus 3 equals plus or minus the square root of 21/4. And then the last thing to do would be what?
Add 3.
Add the 3 over. So x equals 3 plus or minus the square root of 21/4. All right, and if this could simplify, you want to simplify it, but I'm perfectly good with this answer also. Okay, so that kind of helps me to know that you know how to get there. All right, and as I was going from room to room, it looked like you guys were all kind of taking the same approach on each one, which is good because you want to be able to decide with these different methods what is going to be the best way, because on the exam, it's not going to, necessarily tell you on every type of question how I want it solved. There might be a couple where I say solve using completing the square, or solve by factoring, something like that. But sometimes it will just say solve, and you've just got to figure out which method you think is going to be the fastest method, or just maybe the method that works better for your brain, because sometimes there's a couple of different methods that could work, and either one would be just as easy to use as the other. Okay. Any questions on those? You guys did awesome there. Hopefully the breakout rooms worked better this time. It seemed like they were working better. Like I said, some people got kicked out of it, and so if that ever happens, just click on the link again to get into here, and then it will put you back in. It might put you into a different room if it kicked you out of your room and then you got back in. But yeah, just let me know. And make sure also, if you want to try and use your, to unmute yourself and stuff, in the participant box, you got to make sure that that button that says live is red. If you click on it, that needs to be red. Otherwise, it won't let you do anything with your camera or your microphone. Okay, so just know that. There's something a little bit different on this one. Okay, but yeah, if you get kicked out, then just get back into it. Okay, so I want we're going to be moving on to the next thing, but let's go ahead and take maybe a little 5-minute break right now. We've been going for about an hour here, and then we'll get into 10.2 and what we're going to be talking about there. So get up, stretch your legs, you know, go get a drink, something like that. Okay, and then we'll come back and we'll be talking about this next part. Point 2 now, and 10.2 we're going to be talking about the quadratic formula. And so circle that right here, right? So this is the quadratic formula. And you may have heard about this in some other classes, but this is another way that we can solve quadratics, right? So we said we could solve by factoring. We could solve using that square root property if something is, you know, if we complete the square and it's in that squared form. Or we could use this quadratic equation. But in order to use the quadratic equation, we've got to notice that we're going to have something in standard form like we have here on part A. And it needs to be in that form. So everything is on one side of the equation and the other side is equal to 0. And then you'll notice that they have, you know, so ax squared plus bx plus c. So that a, b, and c correspond with the a, b, and c that you see here in the quadratic formula, right? So, and there's like a little song that goes along with trying to remember the quadratic formula. But luckily, you guys won't have to have this memorized because I just found out yesterday that you guys will be able to use notes on your final exam. So as long as they're your own notes or the booklet and stuff like that, you'll be able to use those things. So, but in other classes, you might need to have these memorized too. So it'd be good to try and get it down, right? But it says x equals negative b plus or minus the square root of b squared minus 4ac. And then notice it's all divided by, right? Not the x, but this whole side of the equation is divided by 2a. So it's important to make sure that you notice that it's all over 2a there. All right, so basically with the quadratic formula, a lot of students like this because it's kind of like you're just plugging numbers in and figuring out the answers, right? So once you have it, make sure that it's in standard form. Once you have it in standard form, you're going to just identify what your a, b, and c are. So a is always going to be the coefficient on your x squared term, which in this one, there's like that invisible 1 there. So a is going to equal 1. And then b is going to be the coefficient on your x term. So b is 8. And c is going to always be your constant term. So that's positive 11. All right, so identify what your a, b, and c are, and then we're going to put those into the quadratic formula and then simplify it. So this will have x equals negative b, so that means you got to do the opposite of whatever b is, so negative 8 plus or minus the square root of b squared. All right, so I'm going to take 8 and I'm going to square it. All right. And then minus 4 times a times c. So 4 times 1 times 11, right? And all of this stuff is inside that square root. And then all over, not in the square root anymore, is 2 times a, which is 1 in this case. All right, and now we've just got to simplify this up. So your calculator is going to become your friend on this to help you get this done, but sometimes it will ask you to keep your answer in radical form, or it'll say leave it as an exact answer, right? Or it might ask you for a decimal approximation. Okay, so make sure that you're kind of looking at that. Whoa, what happened there? All right, to make sure that you know which way it wants your answer to be in. Okay. All right. Let's go ahead and work on this then. So we need to simplify what's inside this square root here. So I'll have x equals -8 plus or minus the square root of 64, right, minus 4 times 1 times 11. So that's going to be minus 44. When I multiply those all together. And then on the bottom, 2 times 1 is just 2. All right, so let's keep simplifying this more. So x equals -8 plus or minus 64 minus 64, or 44 is going to be the square root of 20 all over 2. Right? And now, when it wants you to keep it in the exact form, you'll want to make sure that you're breaking down this 20, kind of like we talked about before, where you have to use, you know, the factor tree. You got 4 times 5, and then 4 breaks down to 2 times 2. So that means 2 gets to come out, and 5 is stuck inside. So let me put it next to it here. So we still have -8 plus or minus 2 gets to come out, so 2, and then 5 has to stay inside because it doesn't have anybody to pair up with, and then all over 2. But I'm going to break this up, so when it's saying all divided by 2, that means we're really dividing both terms by 2. So I'm going to write it this way, because that might make it a little bit easier to see when we simplify it. All right, so I'm going to do -8 divided by 2 is -4, and then those 2's can divide out because we've got a 2 divided by 2, and so then I'm just left with plus or minus the square root of 5. Right, so that would be your answer. Right? If it asks you to change it to decimals, then you do -4 plus the square root of 5, change to a decimal, and then -4 minus the square root of 5, change to a decimal. Right? But notice there are 2 answers there, and we're expecting 2 answers because remember our highest exponent, right, the degree of this polynomial is 2. All right, if the highest exponent was a 3, we'd expect 3 answers. If the highest exponent was a 4, we'd expect 4 answers, and so on. Okay? All right, what questions can I answer about that quadratic formula? How many of you, by raise of hands, you find that hand raise button, can you, have you seen the quadratic formula before? Does this look familiar? Raise your hand. All right, looks like there's quite a few. They're saying, yeah, they've seen it before. Maybe you've forgotten a little bit about how to use it, right? But this is what we're doing. Questions on that one, on part A?
There's a lot of questions, but I have a question.
Yeah, put your hands down if you don't, because some of you had your hands up just because you were telling me you've seen it before. Yeah, what's your question?
Oh gosh, I don't know where to start. The first one, for how we set it up, where did we have to put the 1 and 11 in because of the A and C?
Yeah, so do you see right here? So -4 times A times C. Do you see do you see that quadratic formula that I kind of boxed there?
Mm-hmm.
So yeah, so inside there it says to do, what's it doing that?
Oh, I see.
You guys seeing something there that says Module 7 Study Guide Key? I don't know why it's saying that. It's kind of annoying. So make sure that you just know what that quadratic formula is, okay? Let's maybe try another one, and let's see if we can, kind of figure out where, more of your questions are. So first of all, we've got to look at this and say, this is not in standard form. Standard form means we need to get everything on one side and then put the other side equal to 0. All right, so I've got to subtract the 6 over first so that everything is on one side. Right? It doesn't matter which way I bring it, but it's just going to be easier for me to subtract the 6. What's going on? Oh. Subtract the 6 over here. Okay, so that's going to give us 2x squared minus x minus 6 equals 0. Right, so just move everything over to one side. We need the other side equal to 0 to use this quadratic formula. Then identify what your a, b, and c are. Remember, your a is always going to be the coefficient in front of that x squared term. So a is 2. B is the coefficient in front of your x term. And there's kind of a little invisible 1 here, right? So it's going to be -1. So b equals -1. And then c is that constant term, so -6. So it's important if there's a negative sign in front of it that you keep that with the number. That's part of that coefficient. Right. So everybody seeing how we come up with our a, b, and c? Right. And then our quadratic formula, right? If I did the song on it, it's x equals -b plus or minus square root of b squared minus 4ac all over 2a. Right, so it's kind of like Pop Goes the Weasel. Is that nursery or that song thing? Right. X equals -b plus or minus square root of b squared minus 4ac all over 2a. All right, so that's just a way to help you remember that. And so then if we put that in, right, so I'm going to start here. So x equals, and then it says -b, so I need the opposite of b. Right now it's a -1, so I'm going to be putting it in as a +1. Okay. Then plus or minus the square root, right, of b squared. Now you're taking that whole thing, so -1 all squared. Right, minus 4, right, times a times c is the next part of my formula. So times a would be, in place of a, I'm going to put 2. And in place of c, I'm going to put -6. And then my last part of my formula says, to simplify it, so 2 times a, and a in our case here is 2. Okay, so I want you guys to try and take it from there and see what you can do as far as simplifying it like I did on the first one. So simplify inside that radical first. It's going to be the best place to start. let's see if you got to this point at least, and then I'll kind of talk about what we're going to do from here.
Would it be positive 1 or negative 1 when we do negative 1 square root of 2?
So when you do negative 1 raised to the power of 2?
Yeah, isn't it negative 1?
No, it's not, because when we have the negative inside the parentheses, that's saying negative 1 times negative 1. So negative times a negative is going to give us a positive. Okay, good question. That's why I put the parentheses around it too, just to hopefully make sure it stands out. So whenever you're putting any of the number in, whatever you're squaring, whatever number you're going to square in this quadratic equation, that's always, that first number is going to come out to be positive.
Okay, that makes sense. Thank you.
Awesome. Yeah, no, I'm glad you asked. That's a really good question.
That's the step I also stopped at because I got confused with the rest. So
Yeah. Okay, cool. All right, so let's look at kind of the rest of this then from here. So when we add those together, right, inside the square root, we get 49, and 49 is a perfect square. So we can actually simplify this more, right? So it really says x equals 1 plus or minus 7, right? Because the square root of 49 is 7, and then all over 4. And then remember, there's two different answers here, but notice I've got to add or subtract the stuff together on the top, and then I'll divide it by 4. So let me kind of show these out to the side here. So we're really doing 1 plus 7 divided by 4. 1 plus 7 is 8. 8 divided by 4 is 2. So 2 is one of my answers. And then the other way, right, I've got to do the negative way also. So 1 minus 7 divided by 4. 1 minus 7 is negative 6. And then divide that by 4. All right, and all I can do is kind of simplify that fraction, reduce that fraction to give us negative 3/2. So I get 2 and negative 3/2 for my answer. Right. If you got those answers, if you were able to get to that point, will you raise your hand again so I can just kind of see when you were able to get there?
What page is this on?
This is on page 135. And this is part B.
Negative 3/2. Did you do negative 6 divided by 4?
So I reduced that fraction. Right? So 2 divides into 6 and 2 divides into 4.
Oh, okay.
Right? So just reduce that fraction there. Right? And oftentimes you're going to want to keep your answers in these fraction forms. Like I said, on this one it wouldn't really matter, because when you do negative 3 divided by 2, that is going to be negative 1.5. And if you had your answer that way, I would totally accept it. It's just if we were dividing, something by 3, like if we did 1/3, negative 1/3, that's going to be 0.333333333, right? And so you can't really write that down as a decimal. But so what I want to kind of show you here, so if you come out with these, answers here that don't have any radicals left in them, then that means we could have taken this problem from the start and we could have factored it, is what this is kind of telling us here. If they end up with radicals left in the answer, then there's no way that you would have been able to factor that. So a lot of times these will not be able to be factored. And so using this quadratic formula could, you can solve it whether they can factor or not. So that's kind of a nice thing there. So you can do it both ways. All right. Kind of going to not talk about what this is here. I want to talk about something different. So I want to talk about something called the discriminant. Okay, so write this down. So the discriminant is part of our quadratic formula. So remember the part that says the square root of b squared minus 4 times a times c. All right, so the stuff that's inside the square root, right, is the discriminant. So it doesn't have the square root part there. It's just the part without the square root, okay, just the stuff that's inside there. All right, and now the discriminant tells us a lot of different things about our formula, and it mostly is going to give us hints to how many and what kind of solutions we're going to end up with. Okay, so let's look at these. So if you have, I'm going to put this down here, so we're going to talk about 3 different things. So if the b squared minus 4ac, right, so the stuff inside here, if that is greater than 0, or meaning it's positive, right, if the number inside that square root after you've simplified is positive, kind of like we had here, right, on that one, then that means that we're going to have two real solutions. Okay, so you will get two real solutions. Okay, so if it's positive inside there, all right, and that's the same thing that happened here, right? We got that, and so we again got two real solutions on part A and part B, but that's not always the way it's going to be. So another thing that could happen is that that stuff inside, that b squared minus 4ac, could equal 0, right? So if that whole thing inside there simplifies to be 0, then that means you will get one real solution. And the last thing that could happen is if you have that b squared minus 4ac is less than 0, or it's a negative number inside there. All right, so if you have a negative, well, we know when we have a negative inside a square root, those are going to give us imaginary solutions. So you will get two imaginary solutions. All right, so meaning you're going to end up with I in your answer. Okay, and we came up with some like that last time, how we had I as part of our answer, right? And so let's look at one. So turn the page. We're going to skip 136. So go to page 137. I want to talk about these two. We're going to practice using the quadratic formula on these two. So again, remember, and write yourself a little note out to the side to help you remember what we're doing here. We've got to get everything over to one side and put the other side equal to 0. Remember, we had to do that when we, so if we were going to factor this, we had to do that. Move everything over to one side, put it equal to 0. If we're going to use the quadratic formula, we need to do that same thing. All right, so this really is going to be, and I like to keep my leading term positive. So I'm going to choose to bring my negative 3x and my negative 5 over to the other side. So that will give me x squared. When I add the 3x over, I'll have plus 3x. And add the 5 over, I'll have plus 5. And that's going to now be equal to 0. Right? And so now I can identify my A, B, and C. Right? So A will be 1, B will be 3, and C will be 5. And now I'm going to put that into my quadratic formula, right? And I'll write it up here again. X equals negative B plus or minus square root of B squared minus 4AC all over 2A. If we were in class, I'd make you sing it with me. You guys are so lucky we're not in class, right? Okay, so now I want you to put that into the equation and see what you come out with there. Okay, so let me give you just a few minutes. I want you to try and work through it, see where you're getting stuck, see what you already know how to do on your own. All right, so look on the screen and see if you got to this point. It's not done yet, but I just want to make sure everybody got to at least this part. Is there any questions up to that point, how I got those? Okay, you guys are so funny. You make me laugh. You guys would sing it, huh? I think Braxton wants to do a solo. Just kidding. All right. Let's look here. To simplify this further, remember when we have a negative inside that square root, that negative needs to come out as an I. All right, so we'll have -3 plus or minus I times the square root of positive 11. We took that negative out, and as the I, now there's just 11 inside. Okay, but notice that that I doesn't go in front of the plus or minus sign. It just comes right out in front. It's being multiplied, right, by that square root. When you take something out of the square root, it just comes right out in front of that to be multiplied. Okay, and then all over 2. Okay,
What's the I for?
So remember, we can't take the square root of negative numbers, right? It's easier to see if we had, like, if I said like the square root of -25, we're trying to think of what times what, that's the same number, equals -25. And there's not anything, because -5 times -5 is positive 25, right? And I can't make one positive and one negative because I have to have the same number. So there's no way I can take the square root of a negative number. And so in order to deal with these, right, we got to use the imaginary number system, and the square root of -1, Right? Whenever we have the square root of a negative number, that's always going to equal I.
Okay, that makes sense.
So that's what we have to do here. And then we've got to make sure that we simplify this, and we're going to want to have these as two separate terms. So let me show you. So on the next step, I'll do -3, and I'm going to divide that one by 2, then plus or minus this other part, right? So let me see if maybe I can show you. So I'm doing -3 divided by 2, right, will be 1 of mine. And then I'm also doing the I square root of 11 divided by 2. So I'd write that just as I times square root of 11 over 2. Right? And I want it written out in these two separate forms, because remember when we talked about imaginary numbers before, it said to put things in the form of A plus BI, and that's what we have here. Right? Here is our real number part, right, of our complex number, and here's our imaginary number part of our complex number. And so that's how you'll leave the answer on this. You cannot change these to decimal approximations because we can't do anything with that I. Right? So just go ahead and just keep it just like this. Okay? Questions there? And how to simplify that up the rest of the way? So that's our answer.
Finally understood something.
Say that again.
I finally understood something.
Yay! Awesome. All right. Oh, Braxton. He's making excuses now. His pipes are rusty. He's not going to sing a solo for us. Darn it. I was singing a solo, and I am no singer. Tell you what. Okay, so try this one out too. Let's do one more with the quadratic formula. Try and get it simplified as much as you can. Okay, so I'm going to let you start it, right? You know, go from start to finish. Where would you start on this? What are you going to do? So go ahead and try that. And if you get stuck somewhere, pipe up, because somebody else in the class probably is stuck the same place. So just ask. Okay, let's see if you got to this point. All right, notice the inside here we had a -4 times 21 times -10. And so that means it's going to give us a positive 840 inside there. All right, we'll add the 1 to it, and we'll get 841. And that looks like a really crazy big number, but if you try to take the square root of that, it actually comes out nicely. The square root of that is just 29. All right, so we get x equals -1 plus or minus 29, all divided by 42. Okay. Okay, what questions do you have up to that point? Let's make sure everybody's together. Okay, but now we can simplify this more. Remember, I can kind of separate these out because I'm going to have two separate answers. All right, my first one's going to be -1 plus 29 divided by 42. And then my other one is going to be found by doing -1 minus 29 divided by 42. And then I just need to simplify these fractions. That simplifies, or on the top, when I add those together, I get 28, and then 42 on the bottom. But then I can simplify this more. And so if we reduce that fraction all the way, 14 actually divides into both of those numbers, so then we're left with 2/3. Okay, so 2/3 is one of my answers. Okay, and then let's do the same thing down here. All right, -1 minus 29 is -30 divided by 42. So again, I need to simplify these fractions. And on this one, remember that you can see 6 divides in to both of those, so that would give us -5/7. Reduce that fraction. Okay, so 2/3 and -5/7 are our answers there. How many got that? Woot woot, I hope. You're able to get it? What questions do you have? If you didn't get quite there, you know, if there was a place up here that you're like, oh, I'm not quite seeing where Becky got that number, please ask. Don't just stay there in the dark. Try and figure it out. Okay. Well, that's the quadratic formula. Like I said, a lot of people like the quadratic formula because as long as you know the formula, all you're doing is plugging the numbers in and then just simplifying it from there. Right? So you get some practice with that on your homework on 10.2. Right? That's what that one's all about, is the quadratic formula. So I want to move on to 10.3. So turn your page, and that will take us to 10.3. What in the world is happening here? Some kind of weird craziness happened with that. But basically on 10.3, we want to talk about how to graph something when it's in this complete the square form, or been calling it vertex form. And I like to call it vertex form, and you'll see that in a lot of other books, because in this form it's easy to tell where the vertex is. Right? So if I was looking at this function here, right, this h of x equals x minus 2 all squared plus 1. Remember that these numbers tell us the vertex. So the vertex for this, when it's in this form, right, you're doing the opposite of what's inside the parentheses, so positive 2. And then for the y, it's just the number like it is there. So we know that the vertex of this parabola is going to be at 2, 1, right? But that vertex, I want you to think about Don't worry about this right now. But I want you to think about what parabolas look like, right? We either are going to have a right side up parabola or we're going to have upside down parabolas. Right? And we're not going to be talking about parabolas that go left or right. You'll get into those in 1050, but we're not talking about them in this class, so don't worry about those yet if you have that question in your mind. But I want you to see that when we have a parabola, right, there is always going to be a turnaround point. And so that's either going to be the lowest point of the graph or it's going to be the highest point on the graph, right? That vertex is going to be one of those. So if it's a right side up parabola, you're always going to have a minimum value, right? So the vertex is the minimum. And if it's an upside down parabola, then that vertex is always going to tell you the maximum value. Right? And so this is kind of, even though we've been dealing with, I mean, I'm sure you guys have seen a ton of stuff, you know, online about the coronavirus. And even though, you know, it started out exponential, right? And so it's kind of going up like this and it goes up really slow. But you hear people saying at some point it's going to come back down, right? And so it's going to have, and sometimes you'll hear it called the apex, right? But really what it's talking about is some point there's going to be a maximum number of people that get it, and then it's going to come back down, right? So even though it starts off exponential and stuff, it kind of turns into this kind of parabolic shape that we're going to see here on with these quadratics, right? And so for this, right, when I'm looking at this function here, try and so you can see what I'm talking about, right? So this function, we said the vertex is at that 2, 1. Now we want to know, is that a maximum or a minimum for this? Right? Well, since the number, like if there was a -1 out in front of this, that would mean it's an upside down parabola. But it just has a +1. It doesn't show it because, you know, 1 times anything is just itself. So if it's positive, if that first term is positive, then it's going to be a right side up parabola. All right, so we have something that looks like this. And the point in which, you know, and so this is going to be our point 2, 1 if we were to graph it on a grid. And so that means that this would be 2, 1 would be the minimum. And so we're going to kind of be going into talking about this vertex and how sometimes when we're dealing with these, that we're going to have some story problems that we're going to be dealing with, and you'll kind of see, you know, if it asks you to find the minimum, it's asking you to find the vertex of that right side up parabola. If it asks you to find the maximum, then it's asking you to find the vertex of that upside down parabola. Right? So you've got to remember that this max and min is talking about the vertex of that parabola. Okay? All right, so if we were to try and graph these, and my grid kind of, I don't know why it's all messed up here on the side. It doesn't usually look like this. But, so I'll just kind of do my little XY chart out here. Right? So my formula, again, I'll just put it as y equals, and I've got in parentheses x minus 2 all squared plus 1. So we always want to start off, right? We said there's going to be certain points that are going to be best x's to pick. And one of them we said is what makes this part, right, that factor, go to 0? Well, if we put a +2 in place of x, right, that's going to make this go to 0. And then if I try and, you know, so let me put 2 in there, so that's going to be 2 minus 2. is 0, squared is still 0, plus 1 gives me 1. All right, so that means my y is 1. And that gave us the vertex, right? Remember we said if we're looking here, right, those two things are going to give us the x and the y of our vertex. All right, so that's always a good one to pick, right? We also want to pick, you know, something like, sometimes if we put 0 in place of x, right? If we put 0 in place of x and solve for y, this gives us our y-intercept. So let's do that. So if we do 0 minus 2 all squared, right? So let's say negative 2 squared. Negative 2 times negative 2 is positive 4, plus 1 is 5. Right, so we found another point on this graph. Right, and then we might want to look and see, you know, if we can find, you know, some other points on the graph as well. But I want to plot these on here to start off with, just so you can see where this is at. So our vertex is 2, 1, so over 2, up 1, looks like it's about there. Right, and then 0, 5 is my next point, so over 0, up 5 is here. So we can kind of see that I'm going to have a parabola that's going to be right side up. I know it's right side up, right, because it's positive there. And this vertex is my minimum point. So I know it's going to come down here and like this. But remember what we said also last time about the axis of symmetry, right? So the axis of symmetry, right, always happens with these parabolas, because we can, if we were to fold our parabola, right, along that axis, that line that we're going to be talking about here, then the parabola would land, you know, one side would land on the other side if we were to fold it. So we know that the axis of symmetry is always at whatever our x-coordinate of our vertex is. So our axis of symmetry is x equals 2. The line x equals 2. And that's this line right here. So I'll put that dotted line in. Okay. So here's our axis of symmetry. But then remember we said before when we talked about these, we said, well, that's nice because I can see that if I have a point on one side of the parabola, right, so notice how it's 2 places away, then I know in 2 places to the left is where that blue dot is. Well, I know on the other side of my axis of symmetry, 2 places to the right, I'll also have a point. And so then I can kind of see from there, all right, this is what my graph is going to look like. So it's a parabola, it's a right side up parabola, and the minimum value of it is at that vertex of 2, 1. Okay, so we can just kind of look at things and see maybe that, you know, remember the vertex formula is nice because that tells us that turnaround point of the parabola, which is going to give us a lot of information about this. Okay. Now, does this graph have x-intercepts?
No.
Okay, right, it doesn't because it's not crossing the x-axis at all. Right, and so, you know, when we had, let's see, which one was that on? Remember over here where we came up with these imaginary solutions? That's because this graph is never going to cross the x-axis. So when you come up with these imaginary solutions, when you solve this for x, that means that there are no x-intercepts. Right? Because it looks something like what we have here on this graph. Right? It's either above the x-axis like this, or, I'll just draw this other one here so you can see and then I'll erase it, or it could be an upside down parabola, right, that doesn't cross the x-axis. It's kind of floating down here. Right? This one's up here. All right, so in both of those situations, we don't have any x-intercepts. So when we try and solve for the x-intercepts, that's why we get imaginary solutions, because it's not crossing there. Okay, and so that's what's happening on those. Okay, I'm going to get rid of that red one though, so people aren't thinking that was part of the solution there. But remember that we have those two possibilities that could happen. All right, let's go to the next page. Look at a couple of things on this one. All right, so I also want to talk about what if we have something that's not in vertex form, but we're asked to find this. Okay, so I'm actually not going to have you do this in complete the square form, and maybe on yours it doesn't have that on there anymore. I don't know. But I want to show you another way that we can do this. So if it's in standard form, right, everything's on one side equal to 0, we don't have something that's in vertex form, we can still find the vertex of this. Okay. Now again, I kind of want to look at the quadratic formula, because the quadratic formula isn't just like magic. There's a reason why it works and why it's going to work for any of these quadratics. Right, so x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, I think I'm losing my mind, guys. So notice that if, remember how before I said if the discriminant, if the stuff inside the square root went to 0, right, then none of this would exist here. So I'm just going to kind of scratch that out, right? If that was 0, square root of 0 is just 0. And then we'd just be left with this part out in front, that negative b over 2a, right? And this is where we kind of get a formula from to find the vertex, if it's in standard form. Okay, so let's write this down. So the vertex, not the vertex form, but the vertex formula. All right, to find x, the x coordinate, it's going to be negative b over 2a. All right, we're just using that part that's out in front there. That's all we need. So let's look at, so the same like a, b, and c that we talked about before are going to be the same things that we have in there. So if I have x equals negative b, well, on that one it's going to be a positive 12. So x equals negative b, which is a positive 12, right, divided by 2 times a, so 2 times negative 2. Then if we simplify this, we've got, positive 12 divided by negative 4 gives us negative 3. So that's the x-coordinate of the vertex. Right, so let's write this over here. So let's say here's the vertex. Right, the vertex is made up of an x and a y. We just found the x to be negative 3. Right, so that's part of my parabola, part of the vertex of the parabola. Then I need to find my y. And so to find my y, I'm just going to plug, remember this over here, write it down here. Let's see, different color. Let's do this. So remember that k of x, that could just be said as y. Right? K of x is the same thing as y, so I have y equals negative 2x squared minus 12x minus 11. Right, that was the formula that was given, or the equation that was given to me. I just found out what x was. So now I can substitute that into, right, put it in place of my x's that are there. Right, so that means I'm going to have a negative 3 that goes inside this x and also inside this one. Right, so I get y equals negative 2 times negative 3, right, all squared, minus 12 times negative 3, and then minus 11. Right, and now I just need to simplify this. In some of your calculators, well, you can just put it all in there and do that. But if not, you got to use the order of operations. So 3 squared is 9, negative 2 times 9. Right? Negative 12 times negative 3 is positive 36. And then minus 11. Negative 18 plus 36. Minus 11. So I get 18 minus 11, which is going to give me 7. So y equals 7 on this. All right, so that is going to be my y-coordinate. Right, so I don't have to change it to vertex form to find the vertex. I can use this vertex formula to figure out what y or x is, and then to find y, I'm just going to plug, okay, let's see. So to find y, I'm just going to say plug x into given function. All right, now that was quite a bit there that we went over. Phew, you guys like feeling like, oh my goodness, my brain is spinning. What questions do you have there? Uh-oh, somebody's saying, what's happening? I don't know, what's happening? Is there a problem? Not hearing from anybody. Somebody unmute yourself and tell me if you understand it.
I understand it.
Okay.
I feel like this is a lot easier than the other ones.
Okay, good. Right? So it just gives you options, right, of what to do. So some people like the completing the square way more, and some people like the quadratic formula more. Right? And so it's just different ways to do the same thing, depending on what you're starting off with. Right? Okay.
I have a question.
Yeah.
So is this an option to do? So like how we did in 10.12, is there an option to do either way?
Yes. So
Okay.
sometimes, though, remember I said on the test, right, on this next test that we have, it might say specifically that I want you to solve it by completing a square, or it might say I want you to solve it by using the quadratic formula, or solve by factoring, but some cases I'll just say solve, and you pick which way you want to do it.
Okay.
Okay? And you can always, if you're like, I am kind of rusty, like, so maybe you're thinking, I don't know, the complete the square, I sometimes am not quite sure about, but I get this really good. You could always work it out this way, figure out the answer that you get, and then check it, right, with what you get for completing the square, and see if you get the same thing. So yeah, it's just a different method to do the same thing, just like when we talked about solving systems of equations, right? And a lot of you have been working on that car comparison project, but it didn't matter if you graphed it, you did the substitution method, or you did the elimination method. All three of those methods work to get you the answer. It's just sometimes one way is easier than other ways to do it. Okay, good question. I'm glad you asked that. Okay. Now, so on this one here, if we're trying to find the x-intercepts, right, of this, remember I kind of talked about it back here on this last, wait, was it this one? It was over here. Right, I said these, right, what you're finding here when you're finding the x, when you're solving for x, when you're using the quadratic formula, is telling you what your x-intercepts are, right? So our x-intercepts on this one, right, I'm going to write it down this way, so there are x-intercepts, right, are, I've got, so I'm putting 0 in place of y, and then solving it is basically what I'm doing here, and so I'm figuring out what my x's are. So I've got 2/3, comma 0 is one of the points on my graph, and then -5/7, comma 0 is the other point. Right? So these answers that I'm coming up with are x-intercepts. Where is that crossing the x-axis? And like I said, if I get imaginary solutions, then that means there are no x-intercepts. Okay? And that could come out to be one of the things. So sometimes when it says find the x-intercept, let's see where we're at here. Yeah, so when it says find the x-intercepts, maybe those x-intercepts don't exist. They could end up being imaginary solutions. Okay, so let's put next to it here. So when you're trying to find the x-intercepts, you're going to, on this one, I would say use the quadratic formula. Might be the easiest way to solve this. All right. And so you got to look back up here. What is our A? What is our B? What is our C? All right, so I see that A is -2, B is -12, and C is -11. All right, and so you could use the quadratic formula to figure out what these are, what our x-intercepts are here. Okay, so I'm just going to kind of go through this quick. We've done a little bit with the quadratic formula, but I want to make sure get to just one other thing here. So let's work through this. So I'd have x equals +12, right, plus or minus the square root of -12 squared, so that's going to be 144, minus 4 times -2 times -11, okay, all over 2 times -2. All right, so I just put all of those numbers in just like we did before when we were solving the quadratic formula. And now I just need to simplify this, right?
How did we get 144?
Because we did -12 squared, right? So remember our formula is b squared there, okay? And then let's simplify inside there. So I've got 12 plus or minus, so if I do 144, right, and multiply these guys together, so that's going to be 144, and then I'm going to have -44, -88, right, because a negative times a negative times a negative is going to give me a negative number, right? So I've got 144 minus 88. And then that's all over -4, the 2 times the -2. And then if I simplify it from here, 12 plus or minus the square root, if I subtract those, I get 56 all over -4. And then sometimes on this, you know, you could, if you wanted to change it to the decimal approximations from here, right? We're just putting that into your calculator. So let's see, I'll go down here so you can kind of see it. So we'd be doing 12 plus the square root of 56, and then all divided by 4. And then you'd also do 12 minus the square root of 56, all divided by -4. 56 looks weird. Sorry about that. That's 56 inside there. All right, and so then if I put those into the calculator, then I would get, so on this first one, I get x equals -4.9, and on the other one, I get x equals -1.1. Right? And then these, remember, are my x-intercepts. Okay, so that's where they're going to cross the x-axis here. So I've got, you know, -4.9, so it's going to be almost to 5 here. So let me put kind of a little point right there. And then -1.1, so just a little bit more than 1 there. All right. Then I know my vertex, I found that before, all right, -3, 7. So that's the other part of the graph I want to do. So go left to -3 and up 7. Looks like about, this is being weird, that's -3, 7, maybe about there. And so then my parabola is going to look, ooh, wow, that looks Amazing. Right, so up and curved around, and then, oh my gosh.
Sorry, where did we get the 3 and 7?
Remember up above, we found the vertex. All right, so this is the point, this is the turnaround point on our graph. All right, that's the very first thing that we started off with, was where is that vertex? So we used the vertex formula, did the negative b over 2a. We figured out that x was negative 3, and then put 3 in place of x, and solved it for y to find its 7. And so we've got our x-intercepts, and then we got our vertex that we already figured out from above, which was negative 3, 7. So these are kind of 3 different points that we had.
I have a question.
Yeah.
Is it negative 1.1 or positive 1.1?
I can check it again. Let's see. Let's double check here. So when you did
I'm pretty sure it's negative 1.1.
Is that what you guys came up with? Because you're doing 12 plus the square root of 56 is going to be one of them.
Yeah.
So the graph, because the graph is positive.
But it's not, because, yeah, look at the top. Look at our very first equation. What is our leading coefficient? Is that what you mean? Or do you see how it's a negative 2?
No, I'm talking about the X-intercepts.
Uh-huh.
And it's a negative 1.1.
Oh, it is negative 1.1. I said it. I put it down there, but then I graphed it wrong. Thank you. That's what you were saying. I was like, no, I think it's negative, and then I didn't notice that I made a mistake when I was graphing it here. Thank you. That's why it was really looking weird, because I was like,
yeah, you're good. Thank you.
Yeah, no, thank you.
So, for this
All
type
right.
of work, are we supposed to get 2 points then for each one?
Say that one more time.
For this, like graphing and everything, do we have to do both the formulas to get the x and y, and then use the other form to get another point?
Yep. So you had to use the vertex formula to find the vertex, and then you had to use the quadratic formula to find your x-intercepts.
Okay.
Right? If our quadratic started out, if it was nicer and we could factor it, then we wouldn't have to go through the whole quadratic formula. But it wasn't going to factor, and so we had to go this route. And sometimes people look at it, they're like, oh, I'm not so great at factoring, so I'm just going to use the quadratic formula no matter what. It will always work, whether it factors or not. So it might take a little bit more time, but some people are like, but I can get it, right? And so that's, what they want to do. So yeah, 2 different formulas on this one for it. And then that's all you need. You got the vertex, you got the x-intercepts. You could find the y-intercept down here, but really that's enough to figure out what that graph is going to look like, right? Just having those 3 different points that we have there. Okay. All right, well, we need to stop here. So you should be able to get through all of 10.2 homework, and then most of 10.3. We're going to talk a little bit more about 10.3 next time. And then we also need to talk about 10.4. So I kind of didn't get as far as I wanted to. So I'm not going to hand the test out to you then. I'm not going to start it until after class on Tuesday. And then I'll give you probably about 5 days or so to get that completed. And then for you to get uploaded and stuff like that. Okay? So just work on getting your homework all up to date, you know, over the weekend and stuff like that. Get up to through at least 10.2 to make sure that you know, have questions. You can bring them next time and stuff like that, because I'm hoping that we'll have a little bit of time to review over a few things as well, especially things that you have questions about. Okay?
Is all our homework on Affinity?
Yep. Well, except like for module 10, it is, except for 10.4 is going to be a worksheet, but that worksheet is already up there. But we'll go through some of it next time in class.
Okay. Thank you.
Yeah. All right, guys, if you have a couple of questions and you want to stick around and ask, feel free to. And I might have to look for an email from me just in case. I mean, I like some of the things about this one, but maybe we need to go back to WebEx because some people are saying that this one isn't working for them. So look for an email from me and I'll tell you what we're doing. Okay?